Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter Introduction to Atom, about the atoms and the fundamental particles present inside the atoms we are discussing. In this session, we are going to say about the discovery of the first fundamental particles, they are electrons. Okay, let us see about the discovery of electrons, how it is done and by whom it is done. The existence of electrons in an atom was shown for the first time by J.J Thomson in 1897 by passing electricity at a high voltage through a gas at a very low pressure in a discharge tube. So, by the experiment called discharge tube experiment, J.J Thomson found for the first time the existence of electrons. So here, the discharge tube he used for discovery of electrons. There, he passed high voltage electricity through a gas taken in the discharge tube at a very low pressure. Then he observed the presence of electrons in that. Now, let us see what is this discharge tube. A discharge tube is a long glass tube invented by English physicist William Crookes. Means before J. Thomson, William Crookes done several experiments on this discharge tube experiment. Discharge tube. So it consists of a long cylindrical tube sealed at both ends and is fitted to with two metal electrodes. See, this is the blue colored one glass tube is said to be discharge tube, long cylindrical tube, which is closed at both the ends. And inside of this glass tube, they introduced two metallic electrodes, which are used for passage of high voltage electricity into the discharge tube. These electrodes are connected to a source of high voltage. See, these electrodes are connected to a high voltage electric source. And here we know the electrode or metal rod which is connected to negative terminal of the high voltage source is said to be cathode. And the metal electrode which is connected to positive terminal of the high voltage electric source is called anode. So in this way, into this hard glass tube, cylindrical glass tube, two electrodes are introduced and this glass tube is closed at both the ends. Now the discharge tube is filled with certain gas. It is filled with a gas. The tube is connected to a vacuum pump. See here it is vacuum pump. It is connected to a vacuum pump to control the pressure of the gas present inside the discharge tube. So this is a equipment used for the discovery of electrons. This equipment is said to be discharge tube. It consists of hard glass tube, cylindrical glass tube, which is closed at both the ends. And two electrodes are introduced into the discharge tube to pass high voltage current into this discharge tube. And a vacuum pump is connected to this discharge tube to control the pressure of the gas taken inside the discharge tube. So by using vacuum pump, they will control the pressure of the gas taken inside. Now let us see how they have done this cathode ray production. Thomson passed electricity at a high voltage through a gas at very low pressure taken in a discharge tube. So by this, the production of cathode rays was done. But what observations were done at the starting? Let us see those. First of all, when the voltage is high and pressure is normal atmospheric pressure, means around 1 atmosphere, then he observed no electricity could flow through the air. So what he has done? He has taken the discharge tube and he passed certain gas into this discharge tube and maintained a pressure at 1 atmosphere. Now, by passing high voltage electricity through this gas, no electricity passage was observed because we know at normal conditions gases are bad conductors of electricity. The gas taken inside the discharge tube won't pass electricity through it if the pressure is maintained at normal temperature, that is 1 atmosphere. Then when the voltage is high and pressure is reduced to 1 mm of Hg, Then electricity started flowing through the tube. Light was emitted inside the tube. So what happened? So slowly the gas is evacuated by using vacuum pump. Now the pressure of the gas inside the discharge tube is reduced to 1 mm. Means from 760 mm to it is reduced to 1 mm. As the pressure of the gas reduced, the gas started to conduct electricity. As electricity passage is started, then light was emitted inside the discharge tube. So what happened? At normal conditions, by passing electricity at a high voltage, no current was passed by the gas. Then slowly, he reduced the gas pressure inside the discharge tube by evacuating it by using vacuum pump. Then, after reaching the pressure at around 1 mm of Hg, then it started to pass electricity through the gas, and he observed emission of light inside the tube. Then the voltage is high and pressure is reduced to 0.001 mm of Hg. Then walls of discharge tube opposite to cathode ray started to glowing with a greenish light called fluorescence. So what happened? He reduced the pressure still from 1 mm to 0.001 mm. Means almost all the gas is evacuated from the discharge tube. Very few, almost we can say, very few molecules of gas are remained inside the discharge tube now by evacuating. In that way, he reduced the pressure of the gas inside the discharge tube to very low pressure. That is nearly 0.001 mm of Hg was maintained. At this temperature, by passing high voltage current, then the gas inside the discharge tube started to pass electricity. And then he observed that the walls of the discharge tube opposite to the cathode ray are cathode. See, this negatively charged electrode is cathode and the positively charged electrode is anode, as we have seen. Now, by passing high voltage electricity through this discharge tube at this very low pressure, he observed a greenish light, fluorescent light, glowing with greenish color at the back side of this anode. At the back of anode, on the walls of the discharge tube, he observed some greenish light. He called it is said to be fluorescent light. It is observed on the screen, which is fitted at the back side of anode. The fluorescence is due to the bombardment of walls of the tube by the rays emitted from the cathode. So what happened? By passing high voltage current, certain particles, certain rays are emitted from the cathode side and they're passing through the discharge tube towards the anode and striking the backside of this discharge tube. That's why this greenish light is emitted. So these rays which are emitted from the cathode side were called cathode rays as they are being produced from the cathode side. They were called cathode rays. In that way, cathode rays were discovered by J.J Thomson by discharge tube experiment. In the discharge tube experiment, he taken a gas inside the discharge tube and he applied high voltage current on it. At normal pressure, no passage of electricity was observed. As pressure reduced, the electricity passage was started. After reaching the very low pressure, that is nearly at 0.001 mm of Hg, at that low pressure, by passing voltage, then the passage of electricity was observed and a glow was observed and a greenish light passed from cathode side to anode side and a fluorescent glow was observed at on the screen backside of anode. So he called that rays which were passed from the cathode side as cathode rays. They consist of negatively charged particles called electrons. Actually, these cathode ray particles were named as electrons by J.J Stoney. At the earlier by the discovery, they were called cathode rays. They were not called at the starting itself electrons. While it was discovered by J.J Thomson, they called those as cathode rays because those rays are produced from the cathode side and passed towards the anode and fallen in the screen kept back at the anode. So as they are started from the cathode side, they were called cathode rays. But the name electron was coined by the scientist J.J Thomson later. Okay, these particles are negatively charged. These cathode ray particles are negatively charged, which we are calling as now electrons. Now let us see the properties of these cathode rays, now which we are calling as electrons. Cathode rays travel in straight lines. They move in straight lines. If an object is placed in the path of cathode rays, they cast a sharp shadow of the object at the back of the object. Shows that cathode rays travel in straight lines. Okay, in the path of these cathode rays, if any object is placed, the shadow of that place object was uh, created exactly back to that. So from this we can say these cathode rays are moving in the straight lines. If this object, if it is moved up and down, the shadow also moves along with the object up and down. So from this it is concluded that cathode rays travel in straight lines. Okay, because they are creating sharp shadows of the object placed in the path of those cathode rays. Right? Another property, effect of electric field on these cathode rays. When an electric field is applied to a stream of cathode rays, then they get deflected towards positive plate of the electric field applied. Okay, cathode rays will be moving in straight lines as we told. But if an electric field is introduced from the outside in the path of these cathode rays, then these cathode rays, instead of moving in the straight lines, they bend towards the positive electrode. So it shows that cathode rays are negatively charged. We know opposite charges will be attracted. Here, these cathode rays are being attracted towards the positive electrode. This indicates these cathode rays consist of negatively charged particles. These cathode rays are negative in charge. Okay, this proves that. So, cathode rays deviate towards the positive electrode when electric field is applied in the path of those. This proves cathode rays as negatively charged. Okay, next property. Effect of magnetic field on the cathode rays. When magnetic field is applied perpendicular to the path of cathode rays, so instead of applying electric field, if we apply magnetic field in the path of these cathode rays, then they get deflected in the direction which we expect for negative particles. So how the negative particles will be reflected? In the same way, these cathode ray particles also deflected towards one of the sides of this magnetic field. This further confirmed that cathode rays are negatively charged particles. Cathode rays particles contains negative charge. That is proved by this also. Means finally cathode rays deviate from their path in the presence of either electric field or magnetic field. These are affected by both the fields. Okay, in the electric field and the magnetic field, these cathode rays are deviated from their path instead of being in a straight line. Next, cathode rays consists of material particles. This property was indicated by the fact that a light pedal wheel placed in the path of cathode rays starts rotating. We know these cathode ray particles move in the straight lines. If any light pedal wheel, if it is placed in the path of these cathode rays, then it starts rotating. So this proves that these cathode ray particles are creating certain mechanical motion. From this we can conclude that cathode rays consist of material particles. Because of these material particles passing in these straight lines, this light pedal wheel starts rotating. Isn't it? This is one of the properties of cathode rays. Next, charge of an electron or charge of an cathode ray particle. The charge on an electron is quantitatively which is equal to minus 1.602 into 10 to the power of minus 19 coulombs. So this negative symbol indicates the negative charge of the electron. As we said, electrons or cathode rays are negatively charged particles. Each electron carries this much amount of charge, that is equal to 1.602 into 10 to the power of minus 19 coulombs, which is also equal to minus 4.8 into 10 to the power of minus 10 electrostatic units. Simply we say ESU. Okay, this charge of electron is the smallest negative charge carried by any particle. This is the smallest unit of charge actually. Thus, the charge carried by an electron is taken to be 1 unit negative charge, which is also taken as minus 1 charge. So the charge of electron is considered as 1 unit negative charge, and it is a negative charge, then it is indicated as minus 1. Okay, this is the smallest quantity of charge which can exist independently. Okay, this is a charge carried, the smallest charge which is carried by any particle. That's why it is taken as a standard unit, smallest standard of the charge. Okay, 1 unit negative charge it is called. Next, mass of the electron. Actually, the mass of electron is about 1 by 1837 times smaller than the mass of hydrogen. It is a very small quantity. It is nearly equal to 1 by 1837 times smaller than the mass of hydrogen atom. We know among all the existing elements, hydrogen is the smallest in weight, isn't it? It is the lightest element among all the existing elements. So if we compare the mass of the hydrogen atom, the mass of electron is 1 by 1837 times to that of mass of hydrogen atom. So actually to say numerically, the mass of electron is equal to 9.11 into 10 to the power of minus 28 grams, or 9.11 into 10 to the power of minus 31 kgs. This is the mass of electron. So the mass of electron is almost negligible when compared to the mass of hydrogen atom, because it is almost 1837 times smaller than that of hydrogen's mass. So it is, we can say, negligible mass. Okay. Now another property is charge to mass ratio of electron. This charge by mass ratio is called specific charge also. So the specific charge of electron, we can say, charge to mass ratio of a particle is known as specific charge of that particle, or E by M ratio also it is called. Now, the charge to mass ratio or specific charge, which is also called as E by M ratio for an electron, is found to be 1.76 into 10 to the power of 11 coulombs per gram. How it is calculated? Let us see. Charge to mass ratio for electron. We know the charge of electron as 1.602 into 10 to the power of minus 19 coulombs, isn't it? This is charge of electron. If you take the mass of electron, what is the mass of electron as we know? 9.11 into 10 to the power of minus 31 kgs. This is a mass of electron. Now if we calculate, if we simplify these values, charge by mass ratio of electron will be obtained, which is equal to this 1.76 into 10 to the power of 11 coulombs per kg, which is also said to be 1.76 into 10 to the power of 8 coulombs per gram. Okay, this is called the specific charge of electron, which is also called as E by M ratio. This is actually the highest value among, we are going to say about the remaining fundamental particles also. The specific charge is the highest for electrons because its mass is very negligible. Very small mass they are having. So the denominator value is being very small, so the overall value will be the highest, isn't it? So specific charge of electron is highest actually. Right? This is about the properties of cathode rays or electrons. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded videos.